Hey guys, welcome to the first episode of Creating Turgy. In this video series, I'm going to be showing you guys the process of creating a terminal game engine. So I'm calling this terminal game engine Turgy. I've always wanted to create a console or a terminal game engine because I feel like for a lot of newer developers, it's not really fun for them to just print stuff out to a terminal. So I want to give them a framework that they can use to create interactive games that run in the terminal. Also, I think the process of creating this terminal game engine, I think if you watch that, you'll pick up quite a bit. Before we go ahead and start, let me show you a quick demonstration of what I have made so far. So what I have here is basically a little ASCII airplane in a world, so in a scene, and I'm moving the camera or the window around. That's it. Not much, but it's actually the foundation for a pretty solid game engine that we can expand upon significantly in the future. So what I'm going to be using to create this engine is C#. In particular, I'm going to be targeting .NET Core. The reason for this is because I want this to be cross-platform, and .NET Core is cross-platform, and because C# is by far my favorite programming language. That's just my personal opinion. Okay, so the basic idea is that we're going to be drawing characters in a terminal. So there are three main parts to a game usually. Events, or the passing of time, causes things, which are also known as entities, to move around. And then you draw these things in their current location. And then you go back to step one. So events or time causes things to move around, and then you draw them. Event or time causes them to move around, and you draw them, and so on. So here I have a visual for that. Let's say that this is our terminal, right? We're drawing some character. Here I have a star. I'm pretty sure star is part of a Unicode character, but you can imagine this being as a C or anything else, right? We were drawing a character in here, in this spot in the terminal. And then let's say that the user presses the right arrow key. Now we're going to move this character over here, and then we're going to draw it over here. And then let's say that the user pressed the right arrow key again. We're going to move the character one more slot to the right and draw it there. So you can see that we're moving the position of this star character every time the user presses the right arrow key, and then we're drawing it at that new position. And if we wanted to, we could have the star move on its own. Let's say every second. Every second we'll move the star one position to the right. So this is a star that moves by itself. That's why here I said that event or just the passing of time is what causes things to move. And then you draw those things at their new location. And you keep on repeating this. That's basically a game loop. So that's our main idea. Here's a design, meaning the classes that I'm going to create, at least to start with. Now I should note that I didn't just come up with this organization immediately. When I programmed the initial version of this terminal game engine, I had it a little bit different, but I'll present this one. So we're going to have these classes and a few others, but these are the main ones. We're going to have a game class, which represents the game as a whole. This is going to be responsible for handling input and passing it to other things. The game is going to have a reference to a window. The window basically represents the terminal window. So it's basically, just the terminal window. We'll go into more detail later. The window has a reference to a scene. The window draws the scene. So you can think of the scene as the world. The scene is a really large two-dimensional array of characters. That's all. It's just a two-dimensional array of characters. The window is a small box that visualizes a certain area of the scene. You'll see this clearly in a visual shortly. The scene is going to have a bunch of entities inside of it. Each entity is a two-dimensional array of characters as well, essentially. So you have all these little two-dimensional array of characters known as entities. Together they go inside this big two-dimensional array of characters called the scene. A certain area of this two-dimensional array of characters of the scene is visualized by the window. I hope that kind of makes sense. That's our plan. So here's a visual of the scene, right? A scene, as I said, you can think of as a large two-dimensional array of characters. So here I have a character at every spot, but some of these spots could be blank, right? They could have a space character, okay? Now here, this dark rectangle represents the window, right? The window has a position. The position of the window is relative to the top left of the scene. So the window has a position, it has a width, and it has a height. The height is also known as rows, and the width is known as columns. And this rectangle of the window means that the characters in the scene that are inside this rectangle are the ones that should be, drawn onto the terminal window. So this kind of shows that. Here we have our scene out here. And that scene has a bunch of characters. Here the characters are nicely, creating a nice ASCII art. So and we have two entities, right? So here we have a horse entity. You can see that this is a small 2D array of characters that somehow, they kind of shape together a horse. Here we have another 2D array of characters, an entity that represents some mountains, right? We have both of these entities inside our scene. So you can imagine that in our scene over here, we have a bunch of blank characters, blank characters. Over here, we also have blank characters, and then we start having characters for the mountain, etc. I hope that makes sense. And then this dark rectangle, once again, represents our window. So we're going to say that all the characters of the scene that fall within this rectangular region are the ones that need to be drawn to the terminal. So you'd see something like this when it's finally drawn. You saw mostly that horse and a small piece of the mountain. All right, so a little bit more on the main loop. Every game engine has a main loop, and it almost always goes something like this, right? So in an infinite loop, first you handle keyboard events. Well, more generally, you handle events, mouse events, etc. But I've noticed that at least if I want to make this engine cross-platform, C# doesn't give me access to mouse events for console applications. Maybe I'll figure that out later. So anyways, you handle events. Then you allow all of the entities, basically. You allow your scene and all the entities a chance to execute some arbitrary code. This is usually known as the update, right? Then you draw. And you keep doing this over and over and over. You do handle events, update, and then draw. Handle events, update, and then draw. All right, now let's go ahead and take a look at some code. For the code, I'm going to be showing it to you. I'm going to be explaining it on a high level. And then for most of it, you can kind of pause. And if you walk through it yourself, if you spend maybe 10, 20, 30 seconds, maybe a minute on the complex code, on the most complex code, you'll get it. It's much more difficult for me to explain it in great detail than it is for you to just look at it, spend 30 seconds, 40 seconds on it. But I'll give you a high level description of it. Okay, so we're going to start in our program class, which just has our static main method, which is our entry point to our application. This kind of shows you a good example of how the engine is used right now. You create a scene, and the constructor of the scene, you need to specify the width in characters and the height in characters. So this scene is going to have 100 characters horizontally and 100 characters vertically. And then you create entities, right? Here we're going to create an entity. You add the entity to the scene. You can set the entity's position. This is basically relative to the scene. So in the scene, where is the entity located? Let me show you that really quick. So here we have a scene, which is this large rectangle. And then inside our scene, we have two entities, one here and one here. So every entity has a position. That's basically specifying where in the scene this entity is. In particular, where in the scene the top left corner of this entity is. So here's the position of entity 1, and here's the position of entity 2. And again, an entity is just a 2D array of characters. And a scene is also a 2D array of characters. And basically, you can think of as uh, the characters of the scene is just the composition of all the characters of the entities within that scene. Okay, so you created your scene, you created entities, you added entities to your scene, you set your entity's position, and then you call game.start static function and you pass in the starting scene. This basically will start the main loop. Let's go ahead and have a look over here. All right, so here's the start function. Now, I'll describe it on a high level, and then I suggest I'll leave it on the screen for you for a couple of seconds. You can pause and go through it slowly yourself. So again, the start is really our entry point, right? It gets past the starting scene. Now, what we do, the first thing that we do is we use console.cursorVisible equals false to make the blinking cursor of the terminal. You know that blinking cursor that you see in the terminal? We want to make that invisible. That's what this line does. And then we create a window. We pass the scene to the window because remember that a window has a reference to a scene that it's going to visualize. That's what this constructor will do. So we create our window and then we start our main loop. So here we have while true. What we do is we handle keyboard input. So all of this code handles keyboard input. And essentially all it's doing is it's finding out what keys are currently pressed and adding them to a pressed keys list. So it's adding them to a list. And in addition, it's basically emitting two events, a key pressed event and a key released event, which are declared over here. So to summarize, the game class offers two ways for clients to be notified or to find out about key events. One, they can pull. So the game always keeps track of which keys are currently pressed inside this pressed keys list, right? And a client can just consult this list to see what keys are currently pressed. Or they can be notified when a key is pressed or released by connecting to the key pressed and key released events of the game. Anyway, so in the main loop, we handle keyboard events via this code. You can go ahead and have a look at this yourself carefully if you'd like. And then we update. So we basically call the update method of our window. The update method of our window will call the update method of our scene, and the update method of our scene should call the update method of all the entities in it. We don't quite have all of that implemented, but that's the goal. After we handle events, call update, and then we're going to draw. Let's go ahead and see what the draw method will do. Okay, so the draw method of the window. Basically what we're doing is we're using cursor.setCursorPosition to set the cursor position of the terminal to the top left. So terminals have this concept of a cursor position. That's the position that writes will happen to. So if our cursor position is 0, 0, that means at the very top left, imagine the cursor at the very top left of the terminal. And then when you write, let's say you write the character C will appear right there, and your cursor position will be incremented 1 to the right. That's how it works. So we make the cursor position go to the top left, and then what we're going to do is we're going to traverse through each position of the window, and we're going to find the character that's in the scene at that position, and we're basically going to write that character to the terminal window. That's what we're doing over here. So here's all of the code. You can pause and have a look at the draw method yourself here. Okay, now there's a couple of more classes and functions that I'd like to show you. Let's go have a look at the entity class. So an entity just has a position, it has a width, a height, and it has a two-dimensional array of characters that represents the graphics for that entity. So in a regular game engine, pixels are the graphical unit, but in our terminal game engine, a character is the graphical unit. So normally a sprite in a regular game engine is a 2D array of pixels. Our equivalent of a sprite here, we're calling it an entity, and that's going to be a 2D array of characters. And here's a constructor that takes a 2D array of characters and just initializes some properties. You can pause here and have a look at the code for the entity class. Here's all of it. I also want to show you the scene class. Okay, so a scene has a width and a height. This is the number of characters that can fit in the scene horizontally. Height is the number of characters that can fit in the scene vertically. Has an add entity and a remove entity method for adding an entity to the scene and removing an entity from the scene. This basically adds them to an internal list. Has a basic constructor that initializes the width and height. And it creates, so this private attribute called underscore characters, that's the two-dimensional character that represents all the characters of the scene, okay? The update method of the scene, remember that the update method of the scene is called every frame. This dt milliseconds tells us the amount of milliseconds that elapsed, so the amount of time that elapsed since the last time that this update method was called. This is very common in game engines. The update method needs to know how long it was since the last time it was called. And you can use this information to ensure that your game engine runs at the same, essentially that things move around at the same speed regardless of how fast the underlying computer is. The last thing that you want is your entities to move around at different speeds based on the speed of the computer that your game is running on. So but this information will allow you to have it so that your entities move at the same speed regardless of the underlying hardware. So the update method of the scene, basically we're going to use this utility function that I created that basically puts a blank character everywhere in the characters array of the scene. So it puts a blank character everywhere in the scene. And then it goes through all the entities that are in the scene and essentially draws them into the character array of the scene. That's what this BLIT function does. So I think it's worthy to have a look at this BLIT function, right? So what we're saying is, on a high level, is we're saying that take the characters of the entity, draw them onto the characters of the scene, and we're saying that here's the position of the entity. So let's have a look at this method. All right, so the source was the characters of the entity, the destination was the characters of the scene, position is where to draw the source. So let me show you, let me pause here and you can have a look at the code and let me draw to you what's happening here. Okay, so this is what the BLIT function does, right? You have your destination, which is a 2D array of characters, and you have your source, which is a 2D array of characters. And then you have a position that you want to draw the source onto the destination. So if the position was 0, 0, then you're going to draw, then you're going to draw the source right here at the top left corner of the destination. But let's say you didn't want to draw the source right here. What if you wanted to draw it over here, right? Then for your position, you would pass this position. Let me visualize to you the position vector. So here's the position. That's a good visual of the BLIT method. Drawing some source 2D array of characters onto a destination 2D array of characters, and the position is basically an offset where you want to draw the source onto the destination. So again, I'm going to suggest that you pause here and try to understand this code really quickly. I also want to quickly go over our window class. So our window has a position, and this again specifies the area of the scene that the window will visualize. So let me show you graphically. So here is the position of the window, here is its width, and here is its height. Okay, so there's the position variable, here's the scene, a variable, a reference to the scene that the window will visualize. Here's the width of the scene, here's the height of the scene. Those are getters. Here's a basic constructor that you pass in the scene. This is a getter and setter for the position, so you can change the position as well as getting it. These two methods, so the window to scene method, it takes a position specified relative to the window and it converts it relative to the scene. The scene to window method, you pass it a position relative to the scene and it converts it to relative to the window. Let me show you that graphically. Okay, so again, here we have our scene, which is this big rectangle, our window, which is the smaller rectangle, and I have a position, this circle, right? So let's say that this position right now, we'll say that it's specified relative to the window. So it would be something like this. Right? It would be something like this. What if we want this same position relative to the scene? So what if we want this? So we're given this position, the position relative to the window, and we want the position relative to the scene. That's what this method does, window to scene. And you can see that this math is very easy because if you're given this position relative to the window, to get it relative to the scene, you just take this position and you add the position of the window to it. That's it. So let me show you that in vector addition notation. So the position of the window, right, is this arrow. This arrow is the position of the window. This arrow is the position of this point relative to the window. And if you tail to tip add these two vectors, you get this vector. And the scene to window does the opposite. Now we're saying, what if I've given you this position, right, relative to the scene, can you give it to me relative to the window? So can you give it to me like this? And as you can see, these two methods are very small, one line each, but I don't want to have to think about doing that math, even though it's just an offset math, very simple math. I don't want to have to do it every time I want to convert coordinates between window space and scene space. That's why I created these little helper functions. We went over the draw method, and let's have a look at the update method of the window. Again, remember that the update method of the window, of the scene, and all the entities are called once per frame. And frame is a synonym for loop, per iteration of our loop. So when I say once per frame, I mean once per iteration of our main loop. So the update method of the window, what we're doing is we're consulting the pressed keys property of the game to see if W is pressed. If W is pressed, we're going to change the position of the window such that it moves up. If S is pressed, we're going to move the window down. If A is pressed, we're going to move it left. If D is pressed, we're going to move it right. So after we do that, so essentially in response to what keys are pressed, we are moving the window. After we move the window, then we're going to just call the update method of our scene. So remember that let's go back to our game class, right? Our game class calls every frame, it calls the update method of our window. But the update method of our window, after it does its thing, calls the update method of our scene. The update method of our scene, after it does its thing, it calls the update method of each entity. Let's go see if I'm doing that. So we'll go to our scene here. Let's look at the update method. Yeah, so right now all the update method of the scene does is it clears all the characters in the scene and then it blits each entity's character into it. But somewhere here later we're gonna call update of each entity. We haven't done that yet, but we will in the future. So let's see if there's anything else we need to look at in the window class. Nope, that's it. There's one more class that I'd like to show you, the utilities class. So this, we're going to keep a bunch of static helper methods, kind of. So I have this method here that takes a file, path to a file, and it returns a 2D array of characters with the content of that file, essentially. This is because, you know, we're going to be working with ASCII art, and I'm going to have it so that if you just have a file with the ASCII art in it, I can convert that to a 2D array of characters. And remember that we can then assign this 2D array of characters as the graphics for an entity, right? That's why I have this helper method here. So on a high level, all I'm doing is I'm using a stream reader to read every line in that file. I'm going through each character of every line, and I'm creating a 2D list of, basically a 2D list of characters. I'm putting all the characters from the file into a 2D list of characters. And then I take every character from that 2D list of characters and put them into a 2D array. And that's it. So the only reason that this function is kind of long is because different lines in a file can have different number of characters, and I have to make sure that the 2D array of characters here has the same number of characters in each row. I hope that makes sense. So let me show you this so you can read it yourself. Here's the top portion. You can pause here. And here's the bottom portion. And here's the last part. And I believe I showed you the BLIT method. The setChar method, remember, it just takes a 2D array of characters and then a specific value, and it puts that value in every spot in this 2D array. Okay, the last thing I want to note is that make sure that basically when you launch your game through your IDE, make sure that it launches it in an external console, not into the built-in console of the IDE. Here I'm using Writer. I really love this IDE, by the way. I'm using Writer, and I had to go to my configuration. So I believe I went to Edit Configurations, and then I had to check Use External Console. So make sure you do that in your IDE as well. And that's it for this first episode of this series. So far, we have a basic foundation for a game engine, not much besides a scene with an ASCII entity, an airplane, that we can move around the camera on. But it is a foundation, and in the future videos, we'll start implementing things like collision detection, shooting, enemies, all the fun stuff that you see in games. And by doing all of this, hopefully we're going to learn a lot about algorithms, planning, designing, architecting, as well as some coding. So I hope to see you guys in future videos of this series. Bye-bye.